Elements, Essences and Principles. A short essay by Bruce Mills, otherwise known as the Obligate Pedestrian. Although there are different names for the study, chem, alchemy, chemistry, the basic interest is in working out some rules of how substances interact to become other substances. Place water, air and iron together and obtain rust, which is clearly not of the same nature as any of the original materials. Fire was singled out as an influencer. It did not seem to be a material in quite the same sense as water, but it was very good at changing one material into another. In particular, it often seemed to change a complex thing into a simple thing and separate it out into components. Thales seems to be the first person recorded as having speculated explicitly about how this all works. One starts with the idea of ice, which melts to water, which evaporates to steam. Strictly, steam is water vapour rather than gaseous water, in 21st century terms, but that is an anachronistic technicality. To this is added the suggestion that perhaps quartz, which looks a lot like ice, is a form of water that has been frozen so hard that it won't unfreeze. Compare this to the idea of tempering of metals, in which heating and then cooling steel can obtain a much stronger material. The idea is plausible so far, even if the evidence is relatively light. In 21st century terms, compare all this to graphite and diamond being both allotropes of carbon, even though they're extremely different materials. Knowing the elemental composition of a material does not amount to knowing what kind of material it is in an overt practical sense. For many materials, it is not the atoms involved that are important, but the way that they are combined into molecules. The molecules are a much better indicator of the properties of the material than are the atoms. This reaches an extreme with the element of carbon. In the 21st century, chemistry is divided into physical and organic chemistry. Organic chemistry is chemistry involving carbon atoms. Carbon atoms can form into indefinitely large and complicated molecules with attached other atoms acting almost like manipulators on tiny machines. Knowing that something is composed mostly of carbon, hydrogen, oxygen tells you very little about what the material is. It tells you not much more than saying that a digital device is made from transistors and diodes. Going the other way, everything that we call material around us is made of protons, neutrons, electrons and photons, but for the most part it is not how many protons and electrons that are in the material that matters. The ratio is typically 1:1. It is how they are arranged that is vitally important. With this background, the idea of everything being made from earth, water, air and fire, which stand in for solid, liquid, gas and plasma, is not an unreasonable position. There is even a vague analogy of earth to protons, water to neutrons, air to electrons and photons to fire. Vague, yes, but it shows that the logical principle of such a system to explain materials has existed from the beginning. Thales, circa 624 BC to circa 548 BC, is often given credit for the idea that everything is allotropes of water, where water means an essence or principle and not the stuff that one gets from a tap. Empedocles, circa 494 BC to circa 444 BC, is often given credit for the idea that everything is made from earth, water, air and fire. Jabir from the Arabic Peninsula is given credit for the idea that metals are made from sulfur and mercury. In Summa Perfectionis, Pseudo-Geber indicates that there are strong mixtures and weak mixtures of the four elements, leading to the concept that in an alchemical furnace there is little hope, if any, that there would be practical separation of lead into its components that might be reformed into gold. Summa Perfectionis, the William Newman translation, page 147. This is quickly substantiated by reference to 65 VA 1418, already quoted, where the Summa describes the formation of mercury and sulfur within the earth. Here the four elements composing mercury and sulfur are described as corpuscles united per minima to one another in such strong mixture that they cannot be separated. Therefore the two principles are of uniform substance. Quoted by Newman from Summa in Latin, I'm not going to attempt to read the Latin. My translation of it is, but a true mixture of dry, moist, so that the moist is tempered by dry and dry by wet, and be this substance adaptable and moderate between hard and soft and extensive in contusion, it is not created except by prolonged mixing moist, viscous, and fine soil for at least some amount of time, and the same with the dry and the dry with the wet." End of quote. The following is taken from Liber Primus de Naturalibus Principii Mercurii Sulphuris et Arsenici, cap 12, page 17, a 1542 direct reproduction of the Summa Perfectionis. Again, I will not attempt Latin pronunciation. My translation of it is: "In general, however, we will say that each of the two metallic principles, mercury and sulphur, is of a very strong composition and uniform substance, and that therefore, since in them the smallest parts of the earth are as much of the parts of the air, the water, and the fiery are united, so that neither of them is in the other, can be released by resolution." The idea is not absurd. In principle, lead can be separated into protons, neutrons, electrons, and photons, and then reformed into gold. But this requires energies well above those available to Pseudo-Geber in the medieval Europe, and also involves electricity, which at the time was not recognized as an important component of matter. An intermediate point in this is the Farnsworth fusor, designed by Philo Farnsworth 1906 to 1971, by 1964 at Farnsworth Labs. However, Farnsworth left in 1965 due to ill health, dying a few years later in 1971. Robert Hirsch, born 1940, did much of the work producing the Farnsworth-Hirsch fusor in 1967. Hirsch shifted to the AEC around the time of the tokamak. Hirsch became a senior energy analyst for RAND Corporation and was fired in 2003 for criticizing their efforts on fusion reactors. Electricity itself was known in some form in medieval times. Peter Peregrine, circa 1230 to 1300, we don't know his dates very closely, wrote a epistle on magnetism in 1269 that studied the magnetic properties of materials in a manner very similar to the alchemical studies of materials, and inspired William Gilbert 1544 to 1603 in the 16th century. The difference is that by the 20th century it had been well established that chemistry was, at least in principle, a matter of electromagnetics. A grand unification had occurred. In medieval times it was a sideshow only. In alchemical theory prior to 1600, there were several basic concepts of atoms, essences, and principles. The actual division used in this essay is not entirely rigorous historically. Terms did change their meaning, but these are good basic mnemonic names. An atom was a hard, lumpish particle, rather like a very, very small rock. They swarmed around and bumped into each other. They also locked together to create macroscopic, hard, lumpish rocks. This is related to the work on crystals which René Houet published in 1801. It was observed at macroscopic scales that crystals, materials that tended to form in specific polyhedral geometric shapes, such as cubes or octahedrons, also had a tendency to fracture along specific directions. The new surfaces created when the material was fractured tended to line up or have very specific and limited geometric relations to the crystal faces. René Houet did a lot of study of the arrangement of the faces. One observation was that the angles involved were sometimes related to the ways in which shapes, especially spheres, could be regularly packed. In 2 dimensions, circles would be packed in a square grid or in a hexagonal grid, for example. This is a much more definite conclusion from the atomic hypothesis about the macroscopic properties of materials. Compare this to the results of Freund or Boyle, whose atomic theories led almost nowhere. The idea of an essence was along the lines of a fluid or flux. This must not be confused with the idea of an atomic liquid. Some people in the 21st century suggest the idea of an essence that flows through a solid piece of lead to convert it to gold is an absurdity, because it would be impossible to get a fluid to flow through something as solid as lead. However, heat, gravity, electricity, and magnetism can flow through solid metals. So, the error is in thinking that the alchemists of the 12th century meant an atomic fluid in the theory of the 21st century rather than an essence capable of flowing through anything. If looked at in particle terms, electricity is due to a flow of electrons, which is a flow of particles that are small enough to flow between the atoms, even in the most densely packed material. The reason that electrons do not flow through insulators is more complicated. It is something like there are only a limited number of states available and they're all used, but a more complete answer requires quantum theory. A flux of neutrons through a material certainly can transmute it. This idea is used commonly in breeder reactors. Some atoms naturally break apart, releasing energy. That is, some elements naturally transmute into other elements. Uranium-233 is fissile in this way. Thorium-232 has 90 protons and 142 neutrons. It can capture a neutron from the decay of uranium-233 and become thorium-233 with 90 protons and 143 neutrons. In approximate terms, a neutron can turn into a proton by ejecting an electron. If two such beta decays occur in thorium-233, it shifts to 92 protons and 141 neutrons. This makes it uranium rather than thorium, and it also makes it fissile. This would have been interpreted by the alchemists as being an essence flowing through a metal to transmute it into another metal. See Introduction to Nuclear Engineering, Lamarche 3rd edition, Chapter 4, Section 4.2, page 120. Of course, this is nuclear reactions, and it has been suggested that alchemists had no notion of nuclear reactions. However, they did have a notion of strong and weak mixtures. Pseudo-Geber, 1304, Summa Perfectionis, promotes the mercury-sulfur theory of metallurgy. All metals are combinations of mercury and sulfur. Mercury and sulfur are mixtures of earth, water, air and fire. So why not just say that metals were made of earth, water, air and fire? The answer is the same as why in the 21st century it is not said that lead is made of protons, neutrons, electrons and photons. The lead atoms are sufficiently stable that they can be thought of as particles in their own right. In terms of quantum theory, this means that atoms are an effective theory. Not ontologically correct, but a good approximation. In a related sense, one strong idea in mineralogy at the time was that gold was created inside the earth using temperature and pressure that could not be found in an alchemist's furnace and lengths of time in the thousands of years, rather akin to the way that diamonds are thought to be made in the 21st century. So while one could in principle transmute lead into gold, the chances are that the conditions required would be forever outside the scope of human technology. When I wrote that gold was believed to be formed inside the earth, I wrote it in an offhand way as support for the idea that certain alchemical notions were not immediately absurd, but noted that I needed a reference. Since I had mainly read this as a side issue on other topics, I found it hard to get a good compact reference to a clean version of this concept. It clearly needs an entire essay to itself. But I offer Chapter 3 of John Webster's Metallographia, 1671, as plausibly authoritative example. However, much more of that book and several others, such as Physica Subterraneae by Becher, first published as Actorum Laboratorii Chemicae Monacensis in 1669, needs to be read together to get any good idea of the views. Webster Metallographia 1671, Chapter 2, of the generation of metals and whether they grow and have vegetatability or not. It is the general opinion not only of the vulgar, but also of most of the mine men that I have conversed with, which have been no small number, that metals do not grow in the earth, but were all at once created by God, and so have no seminary principle to propagate themselves by, which foolish conceit the most part of learned men have rejected. Nay, even Collegium Conimbrosense itself, and therefore it is needless to waste time in the confutation thereof. End of quote. The Collegium Conimbrosense were a group of late 16th, early 17th century Jesuit philosopher professors at the University of Coimbra College of Arts, originating in 1555. Start of quote. Now, through the whole stream of mystical authors or adaptidists, I have asserted the generation and growth of them, yet have they rather left it as a principle to be granted and believed of their disciples, or handled it so darkly that few have been able thoroughly to understand it, and therefore, as a point most material and necessary, we shall labour as much as in us lies to make it clear, both by reason and observation, from credible authors. End of quote. Now, this leaves principles. It must be emphasized that the words being used here for each idea were not universally used in the manner in which they are being used here. The words have been selected as being often associated with the specific concepts. It is the concepts that are being put on display. The idea of a principle is something like the idea of a property. A material such as samphire can be very salty. This is a property of samphire. This property of saltiness can be transferred to another material, such as beef, by cooking the two together. The thought is that saltiness is due to some specific physical thing, perhaps an essence, that is transferred from one to the other during the cooking process. In this case, in the 21st century terms, the basic idea is correct. Sodium chloride can be transferred by dissolving in water and then being absorbed into the meat. The idea of a principle is that other properties such as weight might also be transferred. This is why the idea of manufacturing gold exists. Lead, for example, already has multiple properties of gold. All one needs to do is to find out how to transfer the remaining properties. It turns out that it is not that simple, but the idea is a reasonable one. Saltiness can be transferred, so can sourness and bitterness. However, weight did not seem to transfer very well at all, and colour transferred only in a partial sense. To make lead yellow, it was not enough to just add some yellow material. There were interactions. For example, sour, that is acid, plus bitter, that is base, makes salty, that is salt. And salty is not the same as sour and bitter. Some combinations of copper, zinc and tin can be used with great success as fake gold leaf. Fool's gold, or pyrite, which is iron sulfide, is actually composed of something that can be yellow, sulfur, and a metal, iron. So this gives plausibility to the idea that gold is iron plus sulfur. Perhaps you just need to get the right allotrope, which might be created by the right heat treatment and other environmental conditions like graphite to diamond. In keeping with the idea of how alchemists describe materials, the Wikipedia has a list of alchemical substances. I feel that the philosophy behind this list is misguided, but the list itself is rather useful. It is misguided because it suggests that there is a unified collection of materials that are alchemical materials. This is like compiling a list of chemical substances. Everything is a chemical substance, but the list is useful as what it really is a list of older terms and translations. From around 1700 to 1900, a theory was developed involving around 100 primary materials. These are listed in what is known in the 21st century as the periodic table. The material list begins with hydrogen, helium, lithium, and so on. This theory was brought to its greatest perfection around the end of the 19th century. Its style is identical to that of the alchemists in the sense of listing the prime materials, finding patterns, grouping kinds, and listing standard reactions. The distinction is only that prior to 1600 there was supposed to be only a handful of primary materials, but 1900 there were around 100. The chemical theory as it existed at the end of the 19th century I like to identify as classical chemistry at its best. It was followed by quantum chemistry that has an entirely different principle. The list of elements is derived from considerations of physical differential equations. One has to be cautious with the correspondence between the traditional alchemical terms prior to 1700 and the classical chemistry terms post-1700. The correspondence is imprecise. What was seen as one substance in 1650 might be seen as being multiple substances in 1750, and vice versa. For example, butter of antimony is translated to antimony trichloride, but that gives a designation in terms of classical chemistry. In traditional alchemical terms, butter of antimony is the substance that is extracted from stibnite by heating it with a corrosive sublimate. The reaction and product are identified by the overt impression on the human senses, how they look and feel and smell. In classical chemistry, materials are identified by a complicated collection of chemical tests that are directly linked to the theory rather than to observation, and in quantum chemistry, to the spectra of the atoms, which is even more deeply dependent on the theory. In alchemical terms, it was recognized that one substance might behave differently, or in classical chemical terms, that the substances had allotropes. The one substance correctly identified as that substance might behave differently depending on how it was prepared. Hence, the precise substance was a matter of stating what the broad substance was and the exact method of preparation. So in chemical terms, one cannot actually know exactly what the alchemists started with, nor what they ended up with, rather than just the bald statement that butter of antimony is antimony trichloride. One should potentially list all the possible substances that could be generated by applying the process as given to the materials identified as given. Often, this would include what would be termed impurities or contaminants, but sometimes the contaminants were important in the subsequent reactions. In chemical terms, sometimes the contaminants were the main contributors to the effect. So using the 21st century pure version of the standard translation would destroy the result, often accompanied by the declaration that the alchemists did not know what they were doing, as the reaction could not possibly work, or the claim that they misidentified the substance. Butter of antimony is so called because it is a yellowish oily fluid that is extracted from stibnite. Stibnite is today identified as antimony sulfide, but in the field the material would not be pure. In alchemical terms, the ingredients might be listed not just as stibnite, but as stibnite from a specific geographical location, hence narrowing down the trace materials in the stibnite. Butter of antimony is any yellowish oily fluid prepared according to a particular basic method. It is not fundamentally antimony trichloride. Butter or oil was a fluid of oily texture, especially if yellowish. Spirit was something driven off in sublimation. Is alchemy then less precise, more approximate and more primitive than classical chemistry? Yes, but not fundamentally so. Traditional alchemy was early chemistry in the sense of just being early, rather than being wrong-headed or non-scientific. Advances have been made. The classical theory was, for the most part, more capable than the traditional theory, but alchemy was not fundamentally imprecise. Alchemists were often very precise, and the laboratory skills of the alchemist probably exceeded those of the modern chemist, who can rely on a supply of pure ingredients and high-tech instrumentation. Classical chemistry would say that diamond and graphite are the same element. They look and behave very differently because of the internal arrangement. They are allotropes of the same element. Often details are determined by measuring the light spectrum, which was not a tool available to the alchemists. But this is essentially the same idea that the alchemists had. There are substances and preparations, and the result is the same substance might behave differently depending on how it is prepared. Since they did not base this off a precise theory of internal arrangement, they focused on the method of preparation. If one preparation produced two different materials somewhat randomly, it would be assumed that there was some detail of the preparation that was being overlooked. The correctness of a preparation could be checked by trialing the substance in certain other reactions. Taken together, this is identifying a material in terms of the details of the way in which it reacts. The following translations are thus approximate, but a starting point for the discussion. Butter or oil of antimony is antimony trichloride. Butter of tin is hydrated tin chloride. Oil of tartar is concentrated potassium carbonate. Oil of tartar per deliquum is potassium carbonate dissolved in the water it extracts from the air. Oil or spirit of vitriol is sulfuric acid. Spirit of box is distilled wood alcohol, that is methanol. Blue vitriol is copper sulfate, green vitriol is iron sulfate, red vitriol is cobalt sulfate, white vitriol is zinc sulfate. The odd one out is sweet vitriol, which is diethyl ether. The last is made from oil of vitriol heated with spirit of wine. Spirit of wine is concentrated ethanol, but this vitriol no longer has sulfate in it. Rectified or rectification refers to the substance being obtained or the process of repeated distillation. Regulus, a rather pure form. For example, regulus of antimony was the antimony metal. The Wikipedia lists antimony regulus as a partially pure form of antimony metal, but I believe that to the alchemist it was effectively the purest. In alchemical terms, regulus was the metallic component refined from the ore. Regulus usually refers to antimony. Regulus of Mars, iron, is actually antimony prepared by roasting stibnite with iron.